How's it going, everyone? Welcome. Lear Gonzalez here, exploring the enterprise UI development, especially here the mocking API request. And I think this is a very mocking API request. This is a very important topic as part of the maintainability of this large code bases, and what are the different stuff that we need to do right now in 2024, especially when you want this to make those large code bases maintainable over time, which is a big deal. And this is something that Grady Butch in that particular podcast when from the pragmatical engineer he described, it says that, hey, again, let me actually just paraphrase that because this is the evolution of software architecture. And I think going back to the basics, to recap and understand and to describe that how do we get here is part of this process, especially on software architecture. In any faculty, or in any domain of expertise. So here, Grady Butch, which is the co-author of the UML, he brilliantly and in an emotive way of describing is how do we get here as now developing UI applications, but specifically how all of this came around. There are also some other very interesting, for example, Grady Butch, and to another, how do you put it? Like this, for example, the computer history machine, when he now
we have the idea
describe is how do we get here, and I continuously using that because it's the simple terms of understand why we're doing the thing that we're doing, and here he present now the little bit of history of computation. I'm not going to dive deep too much into this because this might be just quite off the topic. But again, it's part of the way of how do we understand that, because it's quite. There's a lot, by the way. There is a lot. So, yeah, oh my God. That is quite fantastic.
warfare and use it so that we may move from conflict and move from there to connection. That we may move from destruction to delight and move also from persecution to liberation. The story of computing is the story of humanity, and it's a rich story. Thank you for coming along on this journey.
Again, this might be for another time. Yeah, this is a weird game. The only winner move is not to win. Oh, from this book? Or from this movie, I think it is. Oh, Joshua.
¿A qué no sabes de dónde soy?
Ni idea.
All right, this is in Spanish translation, but in any case, again, I just bring that up here. Um, this is also that I'm going to actually highlight that because uh, I think that what Gratibutch provides to those who genuinely want to understand how do we get here, especially as computer science, as software developers, as UI specialists, which is what we care in this topic, is give us context of why we're doing the thing that we're gonna do, and especially here, mocking API requests as part of these systems that we need to put in place to make all of these older code bases you're gonna inherit at some point uh, manage, make it easy to maintain with a wide range of contributors or a large uh, teams, that there are several systems that now the industry has promote to make the UI development a place where sorry, the UI development a place where we can now have agree upon, so we have an agreement of how we can make this code maintainable. The ability to add or change or refactor code, or sometimes is perform a migration. Now, because of that, and we're gonna focus into these videos on how can we use now particularly tools to help us in that regard. But first, describing it briefly, how do we get here? By understanding that if you inherit this particularly UI code bases, legacy UI code bases, whether it's in jQuery or using just HTML, plain JavaScript, now at least using this new conventions on how we build user interface with React is the way of how not only recognize what React it is, what is the value proposition of React, but also is what are the things that we need to put in place to make this code maintainable. In other words, what are the things that the infrastructure needed to put in place to make that happen. So we look at the unit testing and why a lot of companies actually make a huge emphasis. Yeah. So have a lot of companies actually make a huge emphasis on the unit testing, understand the unit testing, what are the testing, what are the unit that you're testing, and that is JavaScript code, and understand why we use a particular framework to help us in that regard, and the most common operation that we can go with. So for example, to be equal, to be understand is now how the language in itself actually store data values like in a drawer, like a physical drawer, all right? So it store that by values or by reference, so value equality or referential equality, and then some common method that we can use to test our functions, like the to be close to for floating point numbers, also the to contain these elements now is in a collections, to match objects, to to be instance of, to throw errors. Expect.any to check now is the type of this rather than it is value, and then the object array, object containing or array containing, right? And then we move on now to what we care when, how can we now integrate not only the functionality but also your tests in our huge, large code bases with all of this wide range of contributors. So that's what we have, for example, the CI/CD pipeline as a way to now have a systematic and automatic way to integrate code, verify that everything works as expected, and then now operate on that, monitoring, and if we need to add more features, which is something that, of course, as any software needs to do, we can do that and go over the entire process again. So this CI and CD process, we went on how can we now make sure that our code works as expected by putting as a build step, and that our code build correctly by putting as a build step, and that our code work as expected by running as our test. And now using is GitHub Actions, which is now this convenient way where they provide us now this CI/CD servers, so we can run our applications there on those virtual machines provided by them, by defining it as a workflow where you can define series of jobs or bash scripts or custom bash scripts for complex and recurring tasks known as the GitHub Actions, whether it's for catching or for pulling a repo inside of the virtual machines or for set up a correct build tool change in your software or in your build step or your development step, or for example you want us to now set up an authentication with third-party services like in the cloud, whether it's AWS, Azure, and Google, right? So we went through that. We look at how can we do that. How can we also speed up these integrations by catching or generating artifacts? And the catching is for those dependencies that we don't, that are less likely to change those line of codes, like the dependencies. How can we use now a specific custom hook that help us do that? GitHub Actions, and then how can we now move on to the specifications or the security measure that are needed, especially for the repo owners, and that is, hey, now this is entering to the realm of the IT as well as the security and compliance, the IT security and compliance. And what are now the different methods that we have used so far? For example, the castle and modes, and now what we're using is the zero trust policy model. So now, what is the main advantage or the trade-off of each one of those? Where I'm not going to dive into much. And how now, because with the rise of distributed computing, which is makes a lot of sense and for an economic perspective, right? Mm-hmm. For an economic point of view, yeah. That's very interesting. So yeah, for an economic point of view, how that actually is, how can we now build applications that are economical, sustainable, and interesting? So with these distributed computers, uh, the idea is to understand that now that happens on the defense world with ARPANET, and then thanks to Grady Butch and a lot of other developers that actually now see the opportunity on the consumer field, we have now the ability to create these applications, web app applications. So, and to make this much more sustainable and easy to go with and provide value to the clients, we have is this particularly testing library as a way to guarantee that any time that we define UI elements, things won't break behind our back. This is the value proposition of tests. So in component testing, we have the testing library, where now this is a wrapper, as I mentioned before, of these components that is going to be run on like unit tests on JavaScript engines. Here we need to run this component or render this component is on the DOM. That's why we need a platform that allows to run this DOM. That's where we use Node for that. So this server that is now running is a DOM implementations like the GS DOM or Happy DOM, where we can mount these components under the document and body, all right? And well, we can now query elements, or we can run some methods for common user interactions, whether it's for typing and for, how do you put it, for typing key up, which is not a trivial stuff, even though that the name might sound quite straightforward. And also so most overs, and the point is that with this set of methods that are exposed from us, we look also at the challenge, especially when we're writing our tests with this unit testing. But now instead of functions, we are now putting components, and here these components, the ideal word is to test them in isolation without causing any side effects. But for those components who do, let's say you want to render a list of elements that come from an external source, aka Redux, now it makes a lot of sense to actually now develop some sort of patterns for that. So that we have is the test with provider pattern, at least in React. But it also opens up a new way of how can we now write applications that needs to communicate with other components in the system, and that's now emerged, or we are now applying, is this kind of architecture like clean architecture, or the hexagon architectures, right? All of these are trying to now solve the problem of having all of these different components in our applications and how we can make them to interact with each other. This again, that's something that I need to dive deep into the React. I'm not gonna dive deep in today's video, but it's important to at least know that at some point we're going to head towards to that, because what is relevant in today's video is not only recognize that, and also what are the patterns that we can use for our React component, especially if they need, for example, need to communicate with external services, let's say with context or with state. And By doing that, when you need to generate your test coverage, again, which is something that is not strict or is not an exact science here, this kind of test or this coverage, because it shows now is the amount of time that those function actually has been called, and if this might be useful for critical functionalities. So, for example, like utility functions, or for test your Redux, store your state management. All of this specific critical business logic that are going to be used across your entire app. It's also something important here, which is with code coverage. You can use tools like vtest to do that, and help you now to behind the scenes use code coverage from like it's not Istanbul, it's C8, all right, where you can select what is the format of this code coverage that we can go with, and generate an artifact anytime now a build process is being done, okay? But again, code coverage doesn't guarantee that your code doesn't have any bugs. Because what code coverage does is to say, hey, yeah, this function has been called an X amount of time, and this function, and this another function doesn't, right? Oh, during the test. Statement coverage. Similar to line coverage, but count individual statement. Some line may have multiple statements. Branch coverage. Function coverage. Condition coverage. So code coverage now is now line coverage or a statement. Hey, is this was track which line of code were executed? Line coverage, statement coverage, branch coverage, especially if you have now an if-else statement. Function coverage and conditional coverage. But again, it doesn't mean that you don't have bugs in your code. So code coverage actually is not an exact measure for that. But in any case, some company actually wants to go with this. If the CEO wants to talk about that and be whatever it is, well, you know that what you might expect. But again, what is relevant in today's video, all right, after we describe all of this, is now when you need to, for example, test something that you don't control, now is when you mock stuff or spy stuff. So this is a nice segue here, since mocks and spy actually are quite the same. Mocks help you to, or mocks is for replace the functionality of a function, of a model, and the spy is allow you to now verify if a method was called on an object for one single method, right? So you can do here is some introspection and that kind of stuff. But again, a good rule of thumbs or a good recommendation that I follow is that if you want to write your code and you want to test that code that you don't own, there are specific use cases to do that. And that is, well, for things that you don't control. So for example, timers, math randoms, generating unique IDs, sorting elements yeah, for example, sorting UI elements in the API requests. All right. Everything else, as long as you own that in the code, is something that you can test. And if you do that, well, one good approach is to recreate that again. Now, uh, since we went through the spies and mocks and how can we do that, how interesting it is to actually, for example, is mocking third-party libraries, for example, like Fetch or Axios, right? We now here into this and also mock time. So the testing framework provide you is these convenient functions that you can go with. So for example, fake timers, or the other is yeah, fake timers, or set the system date, or set the date, set the system date, so you can fix the system date, right? However, this is good because now we can have this nice convenient functions, utility functions, from the framework, right? The testing framework. However, when it comes to now third-party services and especially APIs, all right, which is mocking API requests, this can become quite cumbersome to do that. And as you can see, with all of this exploration, and to describe why do we get here, is to, from this more abstract concept of computing, we slowly and progressively now flesh out stuff so we can actually have in a way that we can manage that. So mocking API is the way we're gonna do this. In fact, I'm going to create this mocking API for this. So yeah.
The best practice for a really long time, and if you still do it, you have no judgment from me, is mocking out fetch, XAHR, callback. Wow, I don't remember. HTTP request. And one of the things that exist on mobile phones these days are progressive web apps with offline mode. And both of those things, the thing is, mobile phones exist, and one of the things that exist on mobile phones these days are progressive web apps with offline mode.
So, since now computers are not only since now computers are not since now distributed computing is not only based on servers, okay, but also clients that can be laptops, okay, but also clients that can be laptops, and specifically for our case, mobile phones, okay, mobile phones,
and those are
we can now, for this later devices, build progressive web applications. Okay, with offline mode.
And those are powered by service workers. Service workers.
And those are powered by service workers.
exist behind the scenes and they run outside the browser context. Their main job is
so they exist behind the scenes, different in a different process.
with offline mode, and those are powered by service workers. Service workers exist behind the scenes and they run outside the browser context.
So they exist behind the scenes and they run outside the browser context. In other words, it now has its own particular process for it, or in this case, threads. You say service workers. Service worker essentially acts as a proxy server that sits between the web application. Proxy service that sits between the browser. Yeah, we know, but specifically the service work exactly. So they exist behind the server. They exist behind the scenes and run outside of the browser content. So they are like proxies servers between the browser and the network. Sits between the web application, the browser, and the network. They are like proxy servers that sit between. Okay, there are proxy servers that sits between. Sits between. What is it? That sits between. Yeah, that sits between the browser and the network. Exactly, the browser and the network when available. Okay, so there are intent, among other things, to enable the creation of effective offline experience, intercept network requests, and takes appropriate actions based on whether the network is available, and update assets residing on the server. And they will also allow access to push notification and background syncs API. Slow down, because I want to create now is a one from the scratch, bro. Using service worker. Hey, service worker lifecycle. Oh. Okay. Oh, okay. Jesus. This article provides information of getting started with service worker, including basic architecture, registering. Including basic architecture, registering a service worker, the installation and activation process for a new service worker, updating your service worker, catch control, and consent response. And I think before diving into this nice little convenient stuff here that provide for us here. Okay, first it's important to, so before going to look at this, right, industry standard API mocking for JavaScript here, right, mock API in testing to debug network while developing, to present their work across teams, to monitoring ongoing traffic. So writing a single tutorial that will see all of those use cases is rather difficult. There is a good news. However, working with MSW follow the same flow, no matter how and where you decide to use it. Below you can find a complete bare-bones tutorials to integrate a Node.js application. Please note that this tutorial is intended as a working reference, and you're encouraged to follow the additional link of each section below to achieve the integral what you want. Okay. So you got the browser, you got the Node, and you got React Native. Okay. Yeah, let's get into this. Okay. Let's go for this. Let's go for this. Service worker here, API, blah blah blah. Yep, service worker API. Using service worker for the premise of service workers. Okay, all right. So, yep, let's go to get into this, and then we're gonna reverse engineering what it's all about.
Keep this behind the scenes, and they run outside the browser context, calling out to the network. You can intercept network requests from outside of your app and respond to them without hitting the network. So could you mock and stub out fetch or Axios or what have you? That's now code you're not covering, right? Because you mocked it out and replaced it, which means that code coverage tool is never hitting those things, right? It would be really cool if we could get all the way to the edge of what we control, which is basically outside of our browser context, right? And then intercept it. And Sizzle library, that is really exciting. And one of the reasons I want to call it out is test. Yeah, sure. I aspire at every company I work at that I should be able to develop on an airplane.
I aspire every company I work.
Which means in a perfect world, my environment should be set up in such a way that I don't need a network connection to work with it.
Exactly.
There's some jokes about the amount I need to npm install to get my job done, but that's not important. But one of the things that you can do nowadays is, if you look at this even code sample right here, for mock service worker, it looks almost like an Express app if you squint, right? It's basically, you can just write a layer that fakes out your API. The various ways I've done this over time, which is one, just spinning up an Express server that you actually talk to, and just have an environment variable going to localhost whatever port, versus something else. There's different ways that people have done this in the past. This is really great. Sets up a service worker in the context, and what's really great about it is you can use it in your tests to simulate the network. You know where else you can use it? In development. And so this now goes back away from testing and more back to our core enterprisey app stuff, right? Occasionally, I don't know if this has ever happened to any of y'all, you need to work on something before the API is ready. And maybe there's a deadline and the backend team says, we're totally going to have the API done 3 months before that deadline. Has that ever happened to anyone where they actually got it done on time? No, software engineers don't make good guesses. Back end and front end, right? We were sandbagging when we said 3 months. We thought we could do it 2. It took us 4. It took them 4, right? We had a 4-month window to begin with. So what's really great about this is that you can, just for the API that you need too, you don't have to, it's not an all or nothing thing. It will intercept anything to, in this case, in this example we have on the page, a post on a REST API to /login. And then you can control it and do the response to, I think a question one of you asked me earlier, right? When is it okay? This is like we're still sending out the network request as far as the browser is concerned, right? It's just something's catching it right outside and handing it back to us. So you can do all your APIs. You can do just a few of them, right? You can also have it if you like want it to blow up. If it's an unhandled request, you can set that as well. But you can either in your tests start up one of these like mock service workers to basically pretend to be a server. So you're not monkey patching fetch. You're not doing any of those things. Your code is running as it would in the browser. There's just something like outside. It's like we didn't feel bad when we used JS DOM, did we? I mean, maybe you did. I don't know. I didn't feel bad. Right, and the same is true here, where like your code is running the same way it will in production, right? And your tests are actually like your mocking is happening outside of what you control in the truest sense. And I think it's super powerful. But also, I am doing it like a special like sales pitch for those tests. Yeah, sure. Great for development, for APIs that are not done yet, for all sorts of different things, or even simulating stuff that you need to simulate in a certain way. Like, a lot of times, like you might get a bug report, and like you can't get the server to do that thing, and next thing you know, you're like using the app to try to get like staging into some weird condition where you can recreate it. Here, you can literally take the API response, have it be the thing, right? Just use it kind of in development as well. Especially in a large application, like there's tons of things you do not control. There's services you don't own. And so this allows you to put them in various states and simulate a network. Could you spin up your own development server? You could, but now that's the thing you got to spin up next to it. This is basically, you can do like if process.env .nodemp equals development, spin up the service worker, right? Or have something where you don't have it running or something along those lines. You can like have pieces of your code depending on where they're running, just basically use this, and then your code is running the true way that it would normally run, which will give you a lot more confidence. So. Again, some of these things like around mocking stubbing are worthy of like more than we have our time and attention for, and are distracting from the meta point that we're trying to do, which is how do you kind of put the like metal suit of armor around the planet and not unleash Ultron. There, I made the Marvel reference. We can close this section out with that. Made it all the way to the end, which is how do you kind of put the like metal suit of armor around the planet and not unleash Ultron. There, I made the Marvel more than we have our time and attention for, and are distracting from the meta. Give you a lot more confidence. So, again, some of these things like around mocking stubbing are worthy of like more than we have our time and attention for, and are distracting from the meta point that we're trying to do, which is how do you kind of put the like metal suit of armor around the planet and not unleash Ultron.
But for you is but in my case I will go to actually do this right now. So let's get into this. Let's go to create now the enterprise here. We're gonna build is this here. On the test, I want to now say, okay, I want to create here hospital dash rex. Let's say make there of the service worker, worker. Okay, so this is now service worker, and inside of this we're gonna create now several folders. One of them is make dir with the ms mock service worker. Okay, mock service worker. So mock service worker, and here we say I want to install is this by saying npm init with a flag of yes to anything. Okay, here I want to now open up this in cursor, say hey good, do that, right? And please show that on the screen. macOS screen capture. We're gonna say, hey, this will be the service worker, right? So this service worker, the display that you're gonna capture here is a window on the cursor. why they don't have name? Oh, maybe because, okay, let me do something here very quickly. Exactly. Oh, yeah, okay, okay, makes sense. Okay, good, good. There you got it. Sorry for the mess. It must be at the top of this. Whoop, you got it. All right. Service worker, and let's going to make this now in a responsive, almost fit way possible. Okay, okay. Good, good. All right, much better. So that's right. Let's get into this. We define our package JSON. We're also going to install now. Here is the npm like so. Let's say, hey, let's going to install now this latest feature here with this mock service worker. Okay, and we're going to now explore what is that. You can also install that from a CDN. That's interesting. Next, step 2, describe. Next, you describe the network using request handler, get or GraphQL query. A request handler is responsible for intercepting requests and handling its response. So this is now a wrapper around that. So which can be a mock response, a combination of real response and a mock, or nothing. If you only want to monitor the traffic without affecting it. Okay, in this tutorial, let's define a single HTTP request handler for a get, example the user request and response to it with a mock JSON response. So let's get into this. Okay, so here first we define is this particular file called source mocks handlers.js. Okay, but I want to create one. Touch. Oh, so okay, I get it. Okay, so make there. How can I? No, wait a second. How to create a okay, so you say, hey, make there, please, operating system, make there this mocks, okay, and then on the same line when you did to access to the source mocks and create now the handlers.js. Bam! In one line we actually create this, which is a great thing. We say now handlers. And here's where we say, hey, I want you to import using the ES6 model import, not common.js, from MSW. And import is the server, the mock server, followed by this HTTP thing called response, right? Where now next you describe the network using request handlers, okay? And in this case is part of the concept here. They don't mention that. Exactly, part of the concept here, the request handler and response resolver. Please consider disable ad blocker design. Okay. Request handler, of course, I will. Okay. And that is this one. So request handler is a function that describes which request to intercept and how to handle them. You should think of request handler as a route handler you define on a server. For example, here is a route handler with using Express. And here is a request handler for the same reason using mock. So this is some of the concepts that here we're gonna do, which is, hey, it actually is first defining is this request handler from the mock to say, hey, get, all right, and I want to define, here we're going to describe, in this tutorial, let's define a single HTTPS server, okay, request handler for get the example.user. Okay, so this request handler for get, for example, the user, example.com/user, request and responds to it with a mock JSON. Okay, and then responds with this, which is the resolver, or aka the callback, right? Hey, once you get this, right? So I'm assuming that this must be a promise, something like that. HTTP handler. This get and HTTP is now get HTTP handler request. Oh, but this is the HTTP request handler. Okay. Okay, so it's going to fire up this. And here we say now, I want to now return this, intercept the get request. Okay. So here we are now is intercept get requests here, okay, from our server that is going to run locally using a service worker in the client. And anytime we intersect this, I want you down to respond with a modifier, right? In response to then with a mock JSON like this. And that is let's go now to return from this function the HTTP response, okay, dot JSON. That's quite interesting. So what it's doing, to anytime that I intersect this, and again all of this is static, you don't have to wait for that. then you're going to replace with this JSON object, which is, of course, synchronous. And this is now how I'm going to reply for this, right? So this is the JSON I'm going to send over that. So to make this easy to test, we wrap them into a function, export const the handlers here as a collection, can be, right? Yeah, as a collection, like that. All right. So you're exporting is all of this as a collection, and start small with a single handler JS model that contains the entire network description. With time, you can restructure your handle and learn how to override them on runtime. You can describe different API like REST or GraphQL, including the same time in the same handler array. Learn more about describing server API with MS here, but there is no reference into that, no problem. Describing REST API and describing GraphQL API. Again, this is just to make it simple as much as possible. And then you have now the integrate. So you define this, or you describe this, and then you integrate that. So MS integrate with any framework, request libraries, and other tools because it applies itself on the environment level, which means you only have to decide whether you want to use in the browser or in Node, or both. You still reuse the same request handler regardless of the environment you use. So for this tutorial, let's integrate MSW into a plain Node.js process by creating a Node.js integration model called Node.js. So here you create now your mock server, okay, in a different folder now called mocks. Let's go to that. And here say, hey, make their source mocks, and I want to now create this folder called, say, touch source mocks slash Node.js. That's right. Go to the Node.js. Here's where we're gonna create the server, or integrate with our server. So let's go to import now from the MS mock servers worker the setup. Now they call this setup API. What about server? No. HTTP. Okay. Setup server, they call it here. So setup. They renamed this to setup API. But this is a class. And what if where is the setup server, bro? Setup server. That's quite interesting. It doesn't give me that in any case. And also we're gonna import is another model here, that is the handlers. The handlers, that's right. And here we're gonna get is the handlers as a collection and create the server. Say, hey, set up server here. We are running this function to set the server and pass now the handlers as an array. Okay. And store that into accounts called server. Okay. So the question is that if you run this, we recommend creating an environment-dependent integrations model like Node.js and Browser.js, so you can run the same integration across different tools. Any tool in JavaScript run either in the browser, actual browsers, Playwright, Cypress, Storybook, or in Node. VTest, Jest, React Native. Pull in the right integration based on your tools environment and you are all set. The Node.js integration model we have created configure MS to run in a Node.js process, but doesn't actually start it just yet. Exactly. So you just now can integrate that with your server, but doesn't start that yet. So here they define now another folder called, in another folder, say, hey, I think this is on their root, exactly. Touch now on inside of the source, the index.js, that this index is say, hey, I want to now create the server. Okay. And this is part of the integrations here. So here you have now, hey, I want to import from the /mux/node this. This is quite annoying, bro. Don't give it to me. The server, but I don't know why I don't get that. Oh, but this is. God damn. Okay. Then you got it. Yeah, you. Oh my god. Oh my. Okay, server. Jesus. Finally. It's the auto completion feature. Okay, I'll escape. And well, we're going to create now the server here, which is server.listen. Okay. Oh my god. Okay. Okay, server.listen. You pass it the number of the port, all right, and then the function to run that stuff. So listen to this, okay, and because now you can define is this async top level async function, pretty much like a generator function that is going to call app, where by the time I run this, I'm going to now fire and fetch requests and wait for the data to be loaded. Okay, okay, that's interesting. So it say, hey, I want to define here the workflow for this async function to fetch the data here, that is here. Okay, so when you detect this, okay, I want you to await, or in other words, is resolve that promise was resolved properly. If it's not, you can use it as a try and catch to actually now capture error synchronously. In our case, we're doing the happy path. And then once you get that data, I want you get that as a response. Okay. Wait for that response to be processed because it's sending this series of streams. And once all of that is done, all right, I want to make it easy to work for humans in a JSON-like object. So you have now accounts, you're gonna store that as data, and then I want to console log that data, right? So, and after that, of course, run the app here. So, you can also start MBS conditionally based on the node of process or any other criteria. Okay. So if you do now this node source the index, it throw an error because you say, hey, who the F is this? I'm assuming that is Mox node. Mox node. I'm exporting is that server, but it say, hey, cannot use import statement outside of a model. Wait, what? Warning to load ES model. Oh, because here I need to put is on the, okay, I need to tell node, hey, the model that we're gonna use is, or the type will be now model for that. Now once he detect that, it say, okay, now that's good, but it say cannot find this source mock node. imported here. Uh, okay. Wait a second. Wait a single moment. Okay, so to indicate now JavaScript that hey, this will be is now models. All right. To indicate now to know that hey, all of this will be models. So please don't complain about it. Because now it's MGX. It says, hey, request model MS does not provide an export name setup server. Okay. My mistake. Exactly. Because it's node. Makes a lot of sense. So now, if we run this, with all of this MGS models and all that kind of stuff, all right. Now, by the time we run this, it actually gives us as expected, right? So we just intercept this, okay? So we run the server here, and this server now contains this integration that we made for our mock MPI endpoints, and then you say, all right, so by the time we call this on the client, mimic this on the client, I want to get that data here. That's quite interesting and appealing. And that'll be all for this video. Take care. Bye-bye.